In this video, we are going to do important questions with respect to factor theorem. Factor theorem we have already learned in the previous videos. So over here, we are going to do little lengthier and the time consuming questions for which we need to understand that how to do various things step by step. So do watch the video till the end in order to understand about different questions. So let's start with the first one. Without actual division, prove that 2x4 plus 3x cubed minus 12x square minus 7x plus 6 is exactly divisible by x square plus x minus 6. Now, the question says without actual division because we had learned that factor theorem may involve long division, right? So over here, they have just claimed that we should not be getting into that. They are given us the first main polynomial, which will act as your dividend. Now, we need to show that it is exactly divisible by x square plus x minus 6. Now, we have got the divisor, but we are being told not to do division. So what we do over here, first I will name the second polynomial as gx, and it is x square plus x minus 6. So now what we do, we will factorize it. Because when we factorize this, it will give us two factors through which we can get our zeros. So let's start with it. Now, the factors of 6 we know can be either 1 and 6 or 2 and 3. It is 1 over here. So that means the selection is supposed to be for 2 and 3. So what I'm going to write over here is x square plus 3x minus 2x minus 6. Grouping them and taking out common factors simultaneously leaves me with x plus 3 inside and minus 2 over here with x plus 3 inside again. So we have got the final factors as x minus 2 times x plus 3. Now, how are these factors going to help? As I told, they will give us the zeros. So what I'm going to do, I am going to equate each of the factors with 0. X minus 2 equals to 0 and x plus 3 equals to 0. So that means I have got two values of x as 2 and negative 3. The main polynomial was px. So what I'm going to do, I am going to substitute the values of x as 2 and negative 3 in the main polynomial. So let's start with that. I will now name the main polynomial px and rewrite it as 2x4 plus 3x cubed minus 12x square minus 7x plus 6. So we have two values, 2 and negative 3. So now I will start with substituting 2 over here. And that gives me 2 into 2 to the power 4 plus 3 into 2 cube minus 12 into 2 square minus 7 times 2 plus 6. So this results in 2 to the power 4 is 16. 16 times 2 is 32. Then 2 cube is 8 and 8 times 3 is 24. 2 square is 4 and 4 times 12 is 48 minus 14 plus 6. So let's solve that. And what we get, positive terms, 32 plus 24 gives us 56 minus 48 minus 14. That results in minus 62 plus 6, and 56 plus 6 is 62 minus 62, and hence it is 0. That means 2 is definitely a 0, or we can say that x minus 2 is definitely a factor. And we will conclude over here for this one. Therefore, x minus 2 is a factor of px. See, over here I just wrote px. This is the benefit of naming a polynomial. Now, the next thing we need to start for the other value, which was negative 3. So let's substitute. It becomes 2 into negative 3 to the power 4 plus 3 into negative 3 cube minus 12 times negative 3 times square minus 7 times negative 3 plus 6. So now we will solve this. It becomes 81, and 81 times 2 is 162. This is 27 minus 27, and minus 27 times 3 is going to, we have negative 3. So minus 27 times 3 becomes negative 108. Negative 3 square is 9, and we have minus 108 again. This becomes plus 21 plus 6. So now let's calculate. This is positive. This is negative. This is negative once again. And positive and this thing. So what we get over here. Yeah. So what we have over here is, just a moment, it seems negative 3 times 4, it was 81. So it becomes 162. And we have, this is 27 times 3. Oh, yeah, it is supposed to be 81. Okay. So now, yes, the calculations are matching up. So 162 plus 21 plus 6, that results in, if you do the final calculations, it becomes 0. So now what we get over here is that x minus 3 is a factor of px, right? So now we have seen that x minus 2 and x minus 3 both are factors of px. Now we can conclude that yes, the initial polynomial x square plus x minus 6 is a factor of px. So this is how we solved this question. Now let's move on to the next one. If ax cubed plus bx squared minus 5x plus 2 has x plus 2 as a factor and leaves a remainder 12 when divided by x minus 2, we are supposed to find the values of a and b. So now what do we have? We have got a polynomial, main polynomial. We have got the first factor given to us as x plus 2, which is being told that yes, it is a factor. When they are saying that some polynomial is a factor, it means the remainder is supposed to be 0 in that case. And then they're saying there is another factor which is x minus 2, but it is leaving a remainder of 12. And we are supposed to find the values of a and b. So now let's start by naming the first polynomial ax cubed plus bx squared minus 5x plus 2. Okay, so now what we have, the first factor, I'll name that as gx, which is x plus 2. Equating it with 0 gives me x equals to negative 2. Right, now we will substitute in the first polynomial negative 2, which leaves me with a times negative 2 cube plus b times negative 2 squared minus 5 times negative 2 plus 2. So this becomes negative 8a plus 4b plus 10 plus 2. They had said that it is a factor. Therefore, the remainder is supposed to be 0 over here. Now, what do we get? We get minus 8a plus 4b equals negative 12. And what I can see, we have got 4 as a common factor. So I'm taking it out. I'm taking out negative 4 as a common factor, which leaves me with 2a minus b equals minus 12. This gets cancelled and I'm left with 3 over here. That means 2a minus b equals 3. Now, as we had learned earlier in other videos also how to solve for two variables. So what I'm going to do, 2a minus 3 equals b, and this becomes my first equation. So we have got the value of b in terms of a. So far, I had just substituted one variable, one value. Now I'm going to substitute the other value using the other factor, which was x minus 2. So let's start with that. hx equals x minus 2. Now, equating that with 0, So we have x equals 2 over here. Now, in the main polynomial, which was px, substituting 2 over there. Now, what does that leave me with? I am going to substitute. It gives me a times 2 cube plus b times 2 square minus 5 times 2 plus 2. And they have told it leaves a remainder of 12. So I am equating with 12 here on. Simplifying it gives me 8a plus 4b minus 10 plus 2 equals 12. 8a plus 4b minus 8 equals 12. 8a plus 4b becomes 20. Again, removing 4 as a common factor gives me 2a plus b equals 20. Now, cancelling this gives me 5 on the right. So 2a plus b equals 5. This becomes my second equation. So over here I will write substituting 1 in second. And what was my b? b was 2a minus 3. So it becomes like this. That is 4a minus 3 equals 5. 4a equals 8 and a comes out to be 2. So we have found the value of a now. We need to find the value of b. b was 2a minus 3. b equals 2 times the value of a is 2. So therefore, it comes out to be 1. So in this portion, we have seen how to find the value of a and b when one of the factor is a factor giving us 0 as a remainder and other is leaving a remainder, and we solve both of them for 2 variables. Now, let's do another very important question, which is if both x minus 2 and x minus half are factors of this polynomial, we are supposed to prove that p equals to r. It is highly important question over here. Now let's start solving it. We are having one polynomial over here, which is px. And we are given two factors. Gx equals x minus 2. I'll equate with 0 so that I get the 0 of the polynomial, which is 2 over here. Substituting it in the main polynomial gives me p times 2 square plus 5 times 2 plus r. That is 4p plus 10 plus r. Okay, this is the first one, and we are being told that they both are zeros. So this has to have a remainder 0. Okay, now the second one, hx, which is x minus half. I'll equate that with 0 also. So x comes out to be half. Now what we need to do now? We need to substitute the value of half in p. And this becomes p times half squared plus 5 times half plus r. So let's solve it further. And this comes out to be p by 4 plus 5 by 2 plus r. This is 0 also because we were told it is also a factor. I'll number this 2 and the previous one that we had got as 1. So now from here on, they both are equals to 0. So what we can do, since they are both equals to 0, we can equate them. And we will write equating 1 and 2. Okay, so what was the first equation? It was 4p plus 10 plus r equated with p by 4 plus 5 by 2 plus r. Now we will just simplify that. And we have 4p minus p by 4 plus 10 minus 5 by 2 plus r minus r equals 0. What I have done, I have transposed everything from the right side to the left side. Now r and r got cancelled. I'll simplify these two terms. It gives me 16p minus p over 4 plus, taking LCM over here, becomes 20 minus 5 whole over 2 equals 0. 15p over 4 plus 15 over 2 equals 0. Taking out 15 as a common factor, p by 4, or in fact, I am not taking out just 15 as a common factor, but 15 over 2 as a common factor. That leaves me with p over 2 plus 1 equals 0. This is a lengthy portion, though it appears to be pretty easy, but you need to do it very carefully and patiently. Now, we have got 15 by 2 times p by 2 plus 1 equals to 0. So from here, what I'm going to do, I am going to equate 15 by 2, it goes to the other side and dissolves with 0. So we are left with p by 2 plus 1 equals to 0. That means p by 2 equals minus 1, and hence we get the value of p as minus 2. Now, what I'm going to do, substituting p, now you can substitute the value of p in either of the initial one or the second equation which we had marked. So I am just substituting in the first one, which was 4p plus 10 plus r equals to 0. So I'm substituting it over there. I get 4 times minus 2 plus 10 plus r equals to 0. We get minus 8. Minus 8 plus 10 gives me 2 plus r equals to 0. And what we get? R also comes out to be negative 2. So what we can see over here, the value of p is negative 2 and r is also negative 2. That means we can conclude that p equals r, hence proved. I hope you have understood that how to do these long questions using factor theorem. These questions are highly important and they will certainly appear in your school exams. So do watch the whole video carefully, and in case you have any further doubts, you can always comment and subscribe to the channel for further important and learning videos. Happy learning!